Welcome to Ms. Parb's Flipped Classroom. In this lesson we're going to be talking about systems of inequalities, and the objective is to be able to solve a system of inequalities by graphing and then identifying the feasible area. The feasible area is the area where you will find all the solutions to the system. In this example we have 2x minus y is greater than or equal to a negative 3 and y is greater than or equal to a negative 1/2 x plus 1. We want to take this first inequality and solve it for y. So we subtract 2x from both sides and then we divide by a negative 1. Remember, anytime you divide or multiply by a negative 1, you have to change the direction of the inequality symbol. So this goes from a greater than or equal to a less than or equal to. The second inequality is already in slope-intercept form, so we don't have to do anything to that one. The first thing we want to do is graph the boundary line. So we start at 1. And then our slope tells us to go down 1 and over 2. So we go down 1 and over 2 for our next point. And here is the boundary line for y equals a negative 1/2 x plus 1. Since it says y is greater than, we shade above the line. And because it says equal to, our line is solid. Our purple inequality, we would start at 3. And then go up 2 and over 1 to the next point, draw the boundary line, and since it says y is less than, we shade below the line because it says r equal to, this line is solid. In this area right here where the black and the purple overlap from both of these inequalities, this is the feasible area, and this is the area where we would find all of the solutions for this system of inequalities. Any point in this area would make both of these inequalities true. In this example, we have a system, and one of the inequalities is an absolute value inequality. So first of all, this would be a boundary line that would be the horizontal line y equals 3, because there's a y but there's no x. So we graph the line y equals 3, and because it says less than, we shade below the line. And then this would be our parent absolute value function moved to the right one place, because the minus 1 inside the absolute value system, or symbols, tells you to move the graph one place to the right. So instead of being at the origin, we move it one place, and here is our absolute value graph. Remember, it's always in the shape of a V. Y is greater than, so we shade above the line, which is inside the V. The only place where the pink and the blue overlap is this little triangular area right here, and that would be the feasible area where we would find all of the solutions for this system of inequalities. Let's look at a word problem and how we would use this to solve a word problem. Since your city's cultural center is sponsoring a concert to raise at least $30,000, so that means we want $30,000 or more, so this is going to be greater than. For the city's youth services, tickets are $20 for balcony seats, so we let X represent the number of balcony seats, and $30 for orchestra seats. We let Y represent the number of orchestra seats. And the center has 500 orchestra seats. How many of each type of seat must they sell? So Y has to be less than or equal to 500 because we have a limit of 500 orchestra seats. So here are our two inequalities that we're going to graph to find our solutions. On the x-axis we have balcony seats, and that is what X represents. On the y-axis we have orchestra seats because that's what we let Y represent. We graph the boundary line y equals 500 because Y is less than, we shade below the line. And then we graph the line 20x plus 30y is greater than or equal to 30,000. And if we graph it with intercepts, we can cover up the 20x. 30y is greater than or equal to 30,000 would give us y is greater than or equal to 10,000. So we have, 1,000. So we have our y-intercept of 1,000. We can cover this up and solve for x, and we have an x-intercept of 1,500. So using our two intercepts, we draw the line 20x plus 30y equals 30,000. If you don't like using the intercepts, remember you can always solve this for y and graph it that way. It says this is greater than or equal to, so we shade above the line. And this area right here where the pink and the purple overlap are all of the possible combinations of balcony seats and orchestra seats that would meet these requirements.